Good evening, everyone. My name is Sonali. I had a pleasure to work with Atara for last few months. She is amazing. She is very hardworking, dedicated, and she's really smart. She is interested in maybe pursuing career in biomedical engineering or biotechnology, and she wanted to work on something that would give her a lot of that background and understanding. So she worked on a project discovering or understanding how the drugs are developed. So all the drugs that we take, how they are developed. And she's going to talk about that and also give an example of breast cancer drugs. So I'm very happy and proud to be here, and it was a pleasure working with her. Thank you.
So my mentor was Sonali. She has a PhD in biology and she worked in the virology field. She's currently a sales specialist for a biotech company, and she's also serves as their scientific advisor. So first we wanted to understand what is breast cancer. This is a disease I chose to study, and then we're going to talk about the possible drugs used to help prevent it and or treat it. So first we want to understand what are the causes and symptoms of it. So causes of it include hormonal, environmental, and inherited factors. And an example of an inherited factor is abnormal growth of the BRCA1 or BRCA2 gene, which causes it to not produce tumor suppressor genes, leading to the growth of breast cancer cells. Symptoms of it includes lungs, changes in size, redness, pain, and swelling. And some quick statistics about it. So about 1 in 8 women develop it over their lifetime, and in 2014, over 200,000 women were diagnosed. So we want to first also understand the impact of breast cancer worldwide in the United States. So this chart here shows us the rate of breast cancer worldwide. So as we can see here, Belgium had the highest rate from these countries. And this chart on the right here shows the difference in by age and by cases and deaths. So the age range of 60 to 69 had the highest rate of cases and deaths. And then this chart over here compares different ethnicities and races between incidence and mortality. So this chart shows that non-Hispanic whites had the highest rate of incidence, while non-Hispanic blacks had the highest rate of mortality. And then this chart over here explains it shows also comparing different ethnicities and races and compares incidence rate by age. So this chart shows that non-Hispanic whites had the highest rate of breast cancer incidence between the ages 65 and 80. And then this map over here shows us different the death rates between non-Hispanic whites and non-Hispanic blacks by state. So as you can see, the state of California pretty much had the same death rate, but the state of Arizona or Louisiana had significantly different rates. So now we want to understand the process of how drugs go from being in a research to getting onto the market. So the first step is called discovery and development, where molecular compounds are tested to see what possible benefits it can bring. The second step is called preclinical research, where there are in vitro and in vivo studies done to see possible detriments of the combination. The third step is clinical research, which is trials that go for multiple phases, and they increase in size to also test on humans to see also benefits and detriments of the drug. The fourth step is FDA review, and the fifth step is post-market safety, which is continued research that's done on the drug to see as new drugs are constantly entering the market to see if they're compatible with each other. So now we want to understand the difference between prevention drugs and treatment drugs. So prevention drugs are used to prevent a disease from spreading before it actually develops into a full-blown stage, while treatment drugs are used after something has already spread throughout the body. So the prevention drug that I studied is called raloxifene hydrochloride. So it blocks cancer through either blocking estrogen or acting as estrogen in different parts of the body to prevent the spread of breast cancer cells. And there was a phase 3 trial done in 2001 where participants, females 65 and older, were given raloxifene and tamoxifen, a different drug, and compared them. They were given them both together to compare it to see if it would affect memory or verbal fluency or fine motor skills. And the results of this study was that they were able to complete the test successfully, so there was no significant impact on any of those things. And the treatment drug that I studied was cyclophosphamide, and this blocks cancer by attaching itself to the DNA strand of the cancerous cell and prevents it from undergoing mitosis. So there was a clinical trial study done, a phase 3 trial in June of 1997, where participants between the ages of 18 and 75, they wanted to compare this drug cyclophosphamide to another drug, docetaxel, and to see if there was any benefit that would come from this combination. So the results of this showed that 90% of the tests that were done proved to be beneficial to the patients. So I just wanted to end by saying, like, we definitely want to understand the importance of drug testing, and like as society is advancing, new drugs are constantly coming out, and we have to see, like, we have to try to find the right one to like end this after all. And also, it's important to understand the difference between types of drugs to know what's important, what should be given to a patient in this time. That's it. I just wanted to like take this moment just say, like, to thank Sonali for her hard work and like helping me with this project. It was truly a wonderful experience, and I really gained so much learning from this. And I hope to continue learning and studying in this field more in my future. And then later you'll see my demo. It's I'm just going to show around the site clinicaltrials.gov, and this is to like show you how to search for different study trials that are going on, and like how people can actually get involved in participating in them and see possible results that can come out of them.